Yeah, I'm here. I think it's Tuesday morning. I don't know what time. 10, cool. So it'll be 10 to 11:50. And yes, it is cumulative. If you take it during the summer, it is not cumulative. But if you take it during the regular semester, it's cumulative. Okay, so we're going to go over the review today. Basically, I don't know how much I'll finish, but we'll start. If there's any questions, just stop me as we go through. Holy cow, no one showed up. There's a whopping like 35 students out of 107 on a roll. Some people dropped. It always happens. All right, we're ready. Let's get this show on the road. Okay, so obviously we started at chapter 1, right? So that's where we'll start. So some definitions that you probably should know. So the first thing we introduced was the idea of descriptive and inferential statistics. So know the definitions of each of those. So descriptive statistics consist of the summarization, presentation, and organization of data. So it's just explaining data sets with numbers. So, and how do we do that? That was all that chapters 1 through 4 was, or 1 through 5. 1 through 5 was descriptive statistics. Then in the remaining of the course, we talked about inferential statistics. So that was using information from the past to make future predictions. So we created confidence intervals for different parameters like we had in chapter 7. And we did hypothesis testing on different parameters in chapters 8, 9, and 10. So know those two. Then we went over the floor levels of measurement. So 2 of them are quite confusing, so I'm not going to go over those. The last 2 are interval and ratio, those 2. Don't worry about those. Those are confusing, or at least to me they are, so I'm not going to cover them. So we'll just talk about nominal and ordinal. So nominal was whenever you had variables that can be categorized into basically categories, and there was no natural ordering there. And then ordinal, obviously, it was nominal, but there was an ordering to them. So you could talk about like classification of students, class grades like A, B, C, D, F. There's a natural ordering to them. You could also talk about survey results, something like that. Then the next thing we went over was sampling techniques, so how to take different samples. So the main ones we talked about were random, systematic, stratified, and cluster. So a sample is random if every person in the population of interest has an equal probability of being selected. So in this class, for instance, I could pick any one of you with the same probability, and it would be considered random. The next one went over a systematic. So that's when you select every case member. So for instance, I would take every 5th student in this class and look at their final grades. So something like that would be considered a systematic sample. Stratified is whenever you divide the population into subgroups. So you could talk about maybe breaking it up into whether you're in a sorority or not, and then taking random samples from each sorority. So that's an idea of that. You may want to keep that idea in mind. And the last one, cluster. So it's dividing the population into clusters. So you could say, for instance, we're dividing the population of the United States into like the major cities in each state. And then we're going to select each of the, or select a random number of clusters, i.e. the like cities, and that'll be considered a random sample. The last 2 are kind of confusing. Then we talked about observational versus experimental studies, and we talked about a quasi-experiment and then just a classical. So don't really worry about the quasi one. So in an observational study, one merely observes some variable of interest to see how it changes over time. Obviously, observational, they observe. And then experimental, you have a researcher that divides participants into 2 groups. So one was the treatment group and one was, you could say, the control group. And then you assign treatments based on some whatever. So look back at the notes and figure out, look at those examples of how to identify which is which. The next thing we talked about was continuous versus discrete random variables. So continuous could take on an infinite number of values, and discrete could be counted. So like I could count the number of people in this class here. Then we talked about independent versus dependent random variables. So we actually talked about this last chapter as well. So the independent variable is the one that is being changed to see how it affects the dependent variable. So it's also known as the manipulative variable. So know that. And the dependent variable is always be the one, was obviously the one being measured, or you could say it's also the response variable. So keep in mind that acronym ReadyMix, RDY-MIX. That was all we talked about in chapter 2. In 5 minutes. That was quite quick. Was that too fast? Okay, great. Then chapter 2. What was this? This was about graphs, wasn't it? Or was that 3? I think it was graphs. Okay, that's what I thought. Okay. So don't really expect to have to draw the graphs or anything, just know how to interpret them. So we talked about finding the range and mid-range. So obviously the range is the maximum minus the minimum. And then we didn't talk about this in chapter 2, but I'll just mention it here. The mid-range was found by taking the minimum value and the maximum value and averaging the two. It's a rough estimate of the middle. And then we talked about finding the class midpoint. So how'd you do that? It was just like finding the midpoint of anything. You take the lower limit, you add it to the upper limit, and you divide by 2. Know how to do this next part. So calculating the class width. So how do you do that? The class width is equal to the range over the total number of classes. So it utilizes that in the first part, the range is the max minus the min. And then I'll tell you how many number of classes I want. So say, for instance, I want 8 classes and I have a range of 36. Then I can find the class width by taking the ratio of the two. So that would be 36 divided by 8, which is 4.5. And then it utilizes that if you get a decimal, round to the next whole number. So in that case, the class width would be 5. So even if you get a decimal, that's like 3.1, rounded up to 4. Does anyone remember why? Yeah, you can collect all the data. If you round it down, you may have some missing values on the higher end. The relative frequency. So this is basically like the probability of following within one class. So you could find that by the frequency of the class divided by the total frequency. And you can find the total frequency by just adding up all the frequencies of the classes. And the cumulative frequency, so know what that means. So it's the number of values accumulated up to some value. So for instance, whenever we did whatever it was, frequency distributions, you could find the cumulative frequency up to some upper class limit by taking all of the data values less than or equal to that in the data set. Is everyone remembering all this stuff for somewhat? It's been a while. Been a hot minute. 3. Yep, front and back. Some of the other instructors give 2, but I allow 3 since there was 3 exams. And the next thing we talked about was the common distribution type. So just know how to determine whether something is left skewed, right skewed, symmetric, uniform, or bimodal. So remember, the skew is to which tail it has. So if you have a tail on the left-hand side that's much longer, then that's a left-hand skewed. And if you just flip it, it's right-hand skewed. Oops. What does symmetric mean? Yeah, basically you can mirror it across some axis. What's uniform? Basically, it has the same frequency roughly all the way throughout. And bimodal, there's 2 modes. And what is the mode? Yeah, one that occurs most often and more than once. Know that last part. Why does it have to be and more than once? Because if you have numbers in a data set that occur all one time, it's technically no mode exists. So it needs to be and more than once. Are there any questions over chapters 1 and 2? Then chapter 3 was all about calculating statistics. So we first started by talking about the measures of central tendency. So in specific, we mentioned the mean, the median, and the mode. So the mean was the average, the median was the midpoint of the data set, so the 50th percentile, and the mode, I just talked about that. It's the number that occurs most often and more than once. Then the next section was the measures of variation. So how do we measure the variability in our data set? So we talked about the range, so that was the max minus the min. The variance, that was the average sum of squares each distance was from the mean, or each data value was from the mean. And the standard deviation was just the square root of the variance. So make sure you know the relation between variance and standard deviation. Then the next thing it just says find the mean, median, mode, and mid-range. So to find the mean and the median, you can just plug it in the calculator and run one variable statistics on it. It'll tell you the mean, it'll tell you the median. To find the mode, you just look for the number that occurs most often and more than once. And if no number does that, then there's no mode. And for the mid-range, you use the formula above. You take the max plus the min and divide by 2. Then we mentioned how to use the calculator to find the 5-number summary, standard deviation, and the variance. So Ivan was nice enough to write out how to do it. So you go to stat, edit, you enter the numbers that you're interested in into some list, and then you run one variable statistics on that list. And it will tell you the 5-number summary as well as the mean, the standard deviation. It won't tell you the variance, but you can find the variance by what? Yeah, squaring the standard deviation. Then the last thing was how to determine outliers from the data set. So there was 2 rules. So for the lower cutoff, we had that it was any number less than Q1 minus 1.5 times the IQR. And what was the IQR? It was the interquartile range. And how do you find that? Anyone remember? Yeah, Q3 minus Q1. So if you run the 5-number summary on some data set, you can get Q1, the median, Q2, Q3, and the maximum. So then you can actually find these cutoffs by just plugging them in there. Then the upper cutoff was found by any number that was greater than Q3 plus 1.5 times the IQR. And I just said, oh, it even says right there where the IQR is Q3 minus Q1. And what did we use the 5-number summary to create? Anyone remember? Yeah, the box plot. So based on if I give you a box plot, you should be able to figure out what one number of the 5-number summary is. So say I say, what's the minimum? It's just where the last dot is, the left-hand side or the last whisker. If I say what's the mean, just the number in the middle that has that vertical bar. If I say Q1, that's the, how do I describe that? It's the left-hand side of the box where the vertical line is. Does everyone think they could do that? Great. In chapter 4, this homework was awful. I think there was like 20-some questions on it. Okay, so am I going to test you over all of it? No. No. So you should probably know some basic definitions and some basic ideas. So we started out by talking about what the definition of probability was. So in general, it's just the chance of some event occurring. So you could say, what's the probability that you pass the final exam? Hopefully it's pretty high. Then we talked about the sample space. So know that it's the collection of all possible outcomes of a probability experiment. So if I give you some situation and I ask, what is the sample space? You should be able to identify what it is. So for instance, if I roll a die, what's the sample space? 1 through 6, just the numbers I could roll on that die. If I toss a coin, what is it? Yes, the chances are 50-50, but what is the outcomes I'm talking about? Yeah, heads or tails, you can get a head or a tail. And then the definition of outcomes where there's the result of a single trial of a probability experiment. So that just means what happens when you did one trial of the experiment, what were the possible outcomes or what were the possible results you could get? And we called those outcomes. So this next thing, this actually was hidden on your exam 3 somewhere. So the range of values a probability can take on. So for any data value x, the probability of x is in between 0 and 1. So I said, what is the range for a p-value? And a p-value is a probability. So it's between 0 and 1. It includes 0 and 1. Rules for complementary probability, you'll need to know this. There will be a question over it for sure. What? Which one? Rules for complementary probability. So it says for some event E, we have the probability of the complement E bar is found by 1 minus the probability of E, or you could rewrite it as the probability of E is equal to 1 minus the probability of the complement. Or you could say the probability of E plus the probability of the complement is equal to 1. Why do you think that last one gives you the other two formulas? Or why is that last one true? Either something can happen or it cannot. And the probability of each of those added together should give you 1. Because either something's going to happen or it won't. So for instance, if I say, what's the probability that it's going to rain today? And I want you to find what's the probability that it's not going to rain. All you do is take 1 minus the probability that it will rain. I'm actually having to use this in homework I just did for my combinatorics class. But it's a lot harder than this. It's like, what's the probability of not getting 2 tails whenever I toss a coin 25 times or something like that? Okay, and the last thing about chapter 4, we talked about mutually exclusive and independent events, and then we talked about formulators associated with those. So 2 events A and B are mutually exclusive if they cannot occur at the same time. You'll need to know that definition. I know you will. And the associated formula is if I have 2 events A and B that are mutually exclusive, so they can't occur at the same time, the probability of the union or the probability of either of them happening is just equal to the probability of each of them added together. And why is that? In general, the formula is the probability of A plus the probability of B minus what? Anyone remember? The probability of the intersection, right? So if 2 events can't happen at the same time, the probability of the intersection is what? 0. Next, 2 events A and B are independent if one event occurring does not affect the probability of the other event occurring. So for instance, whenever we talked about tossing a coin, the 2 consecutive tosses are independent of one another because what happens on one toss is not going to affect what happens on the next. So therefore, we said the 2 events were independent, and you can find the probability of the intersection of the 2 events by just multiplying the corresponding probabilities of each. Is everyone okay up to that point? Okay, and then chapter 5 was all about discrete probability distributions. So in chapter 5, what specific distribution did we talk about? Does anyone remember? Yeah, binomial. So know that the binomial distribution is a case of a discrete distribution. Simple as that. So, and then given a discrete probability distribution, you can find the mean, the variance, and the standard deviation. So I made you do that on the first exam. Actually, I think I did. So the mean is just the expected value. So you can take each individual outcome that the random variable can take on, multiply it by its corresponding probability, and then add them up, and that would give you the mean. You could find the variance by that formula there. So if I say find the variance of something on the exam, I don't expect to give you a discrete probability distribution because it would take a little bit of time to do it. And the exam is quite long. If you want a rough estimate of how long it is, just look at the practice exam. I think the practice exam has 20 true and false, 20 multiple choice. And then it's either 3 or 4 free response questions. So what do you think the free response questions will cover? Yes, very good. So there may be a question on there that seems very familiar. If you paid attention to which one I said was pulled straight from an old final exam, you'll know which one it is. If you don't, then I'm sorry. There's probably a group me for the class so you can tell everyone else. And I probably get roasted in it, so don't worry. Okay, and then the standard deviation was obviously the square root of the variance. So if I put a question on there that says, I have a standard deviation of this, find the variance, guaranteed there will be one of them that is the square and one that is the square root. Please pick the correct one. I guarantee most people will get it right. Some people will get it wrong. What happens if I give you the sample size? Does that factor into the standard deviation calculation anywhere? The trick question, no. If I ask for the standard error, it does. If I ask for the standard deviation, it does not. Then we talked about the binomial distribution. You may need to know the 4 conditions. I can't remember if I did that or not. I can't remember. Does anyone remember the 4 conditions for it? So they were, so a set number of trials. Two outcomes per trial. I'm trying to write it small so I can get it right in between these lines. Anyone know the other 2? So the probability of success, P, remains constant. Anyone remember the last one? The trials are independent of one another. Just say independent trials. So you may need to know those. Then, given a set number of trials N, the probability of success P, and the probability of failure, which is Q, just 1 minus P, then you can find the expected value of X by just N times P, so the number of trials times the probability of success. The variance of the random variable by taking the mean times the probability of failure, and then the standard deviation by just taking the square root of the variance. So there would guaranteed be something like that on the exam. I will ask you to find one of them. So if you remember the formulas, it'll be easy. I guess if you wanted for your cheat sheet, you could shrink this down and literally copy that, but you may want to put examples on there. Is everyone okay up to that point so far? Do y'all want me to go over some possible questions from those chapters or just keep moving on? Yeah. Okay. So do I have my old final? What did I give last semester? What was that, fall 2021? Oh, whoops. Thank you for letting me know. Did I hear that correctly? 3 pages of notes for the exam. Yes, front and back. Fall 2021 elementary statistics. Where's their final exam? There it is. Okay, so something like this you could expect. So the first one, the branch of statistics that consists of the collection, organization, summarization, and presentation of data is what? That's just the definition of descriptive statistics. College major. So it asks you to identify what type of variable that is. So college major is just a category and there's no obvious ranking to them. So therefore it is nominal. Blood type. It's nominal. So there's no order to specific blood types, I guess. I don't think there is. So I'm going to consider it nominal. Weight. That was one of the examples we said for a continuous random variable. You can take on theoretically any weight in between 0 pounds and whatever the highest weight is. I don't know. Then the next one, in a blank sample, all members have an equal chance of being selected. I just went over that. It's a random sample. The difference between the highest and the lowest values of a data set is called the range. This one, I think, was one of the tricky ones. The sum of the blank of a frequency distribution always equals 1. So that's the relative frequency. So the relative frequency is the relative probability of each class. So whenever I add up the total numerators, it should add up to the total number of data points divided by the total number of data points, which is 1. If you put cumulative frequency, that is wrong. And why? So the final cumulative frequency will be what? Yeah, it'll be the total number divided by the total number, which is 1. And then I'm adding up the rest of those to 1. So it's going to be greater than 1. The class width for a data set with 8 classes and a range of 27 is what? So 27 over 8 is what? Anyone got a calculator? It's like 3.375, I think, if I remember right. So since it's a decimal, round it up to 4. Then the graph, just know how to tell. So the tail is to the left. There's not a good chunk of data on the left, but all of it's, or not a good chunk of data on the right. It's all on the left. So therefore it's skewed to the right. That happened last semester too, whenever someone's ringtone went off and I danced. Okay, which the following is not a measure of central tendency? So I'm just asking which one is not a measure of the middle. So the mean, the median, and the mid-range are all measures of the middle. Therefore, the only one that isn't is the range. The range is a measure of what? Variation. Then a blank is a value computed using all the data values in a specific population. So that's just a parameter. If we use sample values to calculate, then what would it be? Yeah, statistic. A data set with two modes is called what? Bimodal. What if it has more than two? Yeah, multimodal. Calculate the median for the data set. I guess I wasn't nice enough to order them. So there are 1, 2, 3, 4, 5 numbers. So it'll be the middlemost. So it'll be the third. So that would be 5, 11, and then 22. So 22 is the middlemost. Number 14, what denotes the population standard deviation? It's just sigma. What if it was sigma squared? What would it be? Yeah, D. If it was S, what would it be? C. And if it was S squared, it would be A. Calculate the variance of the sample. So all I wanted you to do is plug that in the calculator. So if you do that, I can't remember what in the world you get. So the only thing you need to be careful of in this case is whether you're looking at SX or sigma X and squaring that. So which one is it in this case? SX, because that's of the sample. Number 16, the probability of an event is between and including what two values? 0 and 1. We went over that. What one? Let's see. What does number A correspond to? What values are in between -1 and 1? Anyone remember? We talked about it in chapter 10. Yeah, correlation coefficient. And I didn't talk about it last time in class, but it was in the video online. What other value is between 0 and 1? Anyone remember? Coefficient of determination, R squared. Oh, I also didn't mention in class. Has anyone found chapter 10 homework kind of iffy or not? Because the way it kind of does is kind of confusing. Okay, so I'll explain it this way. Whenever it goes to those questions that says the equation of this line is whatever, so that depends on whether you reject or fail to reject the null hypothesis that there's a significant linear relationship. So in those examples, it gives you a value of the sample correlation coefficient, right, R. So what it wants you to do is find the critical R and see if that it results in a rejection of the null hypothesis or not. If it does not, then select the one where it says, what does it say? I can't remember. It's the second option, the one that says you don't need to do a test on it. If it is, select the first option. Oh, that's the other way around. The first option is the one that says there is not one. Second is there is one. So you'd select the first one if there isn't a rejection of the null hypothesis, and the second one if there is. And then you would enter in the corresponding values for A and B. Does anyone remember how you can do that on the calculator? So it'll actually run the test for you if you run linreg t-test. But make sure you have the variables X and Y in the right order and identified correctly. What did someone say in the chat? The graphs are hard to get just right. Do you have to make graphs in there? Oh, lovely. Oh, lovely. How many points are there? Okay. Okay. Does it not let you enter in like different values for X and Y? Oh, dang, it's not as easy. Oh, lovely. Well, at least there's only two. You want me to go over some of the problems from 10? I don't care. It's up to y'all. Okay, cool. Let me do this last couple things that go over up to chapter 5, and then we'll do it. So 2 events are blank if they cannot occur at the same time. That's just mutually exclusive. Know how to do something like this. On the menu, there are 3 appetizers, 4 entrees, and 2 sides. How many possible meals can be made? So you have 3 options for an appetizer. You can choose any 3. You have 4 options for the entree. You can choose any 4. And you have 2 options for the sides. Therefore, you can find the total number of possibilities by multiplying each of them. 3 times 4 is what? 12 times 2 is what? 24. See. Number 19, the coin is tossed 5 times. Find the mean number of heads that will be obtained. This is just a binomial problem. So the probability of success is the probability of getting a head on one trial. And what's that? 0.5. So you have P is 0.5, N is 5. So just multiply the 2. And you get 2.5. How many tosses would it take to get a mean of 25? 50, yeah. All right. Well, that's all the ones that would cover something like that. How many questions were on here? 30. Okay. So it's a little different. I didn't give them true and false last semester. Okay, let me go over here on this side. Share. Share. Alex. Assignments. Assignment. Let's do this. Okay, so I'm pretty sure this question will change for some of you. So what is meant by the statement the variables are related? What in the world? Choose the correct answer. 2 our variables are related when the value of one can be derived mathematically from the value of the other. 2 equations are related when a scatter plot can be made of points using 2 variables as values. 2 variables are related when a change in one can be shown to cause a change in the other. 2 variables are related when a... What in the world? It can be like 2 of those. Derived mathematically from the value of the other. That one doesn't really make sense. 2 variables are related when a scatter plot can be made using the 2 values. I don't think that is it. I think it's this one. Ta-da. Okay, this one is just interpreting the value of the slope. So a positive relationship means that the 2 variables, as x increases, y what? Yeah, if you have a line like this, as x increases, y increases. That's all it's saying. A negative relationship between 2 values or 2 variables, as x increases, y decreases. That's just interpreting the slope. This one, in a regression line and statistics, the symbol for the slope is what? Anyone remember? So the general form of the line we talked about was y prime equals a plus bx. A was the y-intercept and b was the slope. As the value of the correlation coefficient increases from 0 to 1 or decreases from 0 to -1, how do the points of the scatter plot fit the regression line? Which one do you think it is? Yeah, closer to the line. Because as the correlation goes to 0 or to 1, that means it's getting a stronger and stronger correlation. So most of those points are going to lie close to that line. And the same idea works for getting close to -1. If it was going from 1 to 0 and -1 to 0 would be the second one. They would be scattered further from the line because the closer to 0 it is, the closer there is to being no relationship between the two variables. Number 5. Oh, so something like this. Let's see. Okay, so 67 to 2.3. What in the world? 67, 2.3, somewhere right here, maybe. Oh, I can click the pencil. Lovely. This is not fun. Oh, okay, so this is okay. 67, about right here, and 2.3, right? Probably somewhere right there. 81.16 and 2.5. 81, so probably right here, 2.5, so probably right around here. 87.76 and almost 3. 87, so probably around here. Let's say almost 3, so probably right there. 52.63, 5 point something. 60, wait, did I just say that right? 52.63. So somewhere around here. And what was it? 2.451. So almost about right here, I guess. Oh, crud. Dang it. I say it was 2.3. Right here, good enough. 50 and 2.37. Okay, now I can see why I'll get frustrated with this. 84.21 and 2.89. 84, probably around here. 2.89, it said. Yeah, okay, somewhere around here. Let's see if it takes that. Woo! Dang, I'm good. Get as close as you can. Then it says compute the value of R. How do you do that? One easy way, plug it in a calculator. Then once you have the value of R, I'm going to skip it because it'll tell me what it is. Then it says state the hypothesis. What is the hypothesis for the test? The two will always be the same. So the null hypothesis is there's no linear relationship. So what value is equal to 0? Rho, yes. And what is the alternative? There is a linear relationship, or yeah, it does not equal 0. I don't care. Oh, skip it. See, this is the good part about being a teacher. It'll just, I don't have to do it. Test the significance of the correlation at alpha is 0.01. So that means I want to see what's the critical R value. So you just click this thingy. What was the sample size? Oops. Here. So there were how many pairs? 1, 2, 3, 4, 5, 6 pairs. So the degrees of freedom you use is 4. So you do 4 and 0.01. So the critical R value is 0.917. So be careful because Alex wants the plus or minus of this. So just do plus or minus 0.917. And then you look at whether your correlation coefficient you got is between the negative 0.917 and the positive. And if it is, you fail to reject. If it does not, you reject. So R 0.791 is in between these two, so you do not reject. Then it'll ask for a brief explanation. So it says there is or is not a significant linear relationship. So since you did not reject, what is it? Yeah, it is not. What else? This one is what I was talking about. So the correlation coefficient is 0.918 and alpha is 0.05. Should a regression analysis be done? So what you need to do is look at the critical R value in the table. So someone look for 1, 2, 3, 4, 5, 6. Look for 4 and alpha is 0.05. What is the critical R value in the table? So it's 0.811. So the absolute value of the sample correlation coefficient is greater than the critical value, so it should be done. And then you just plug in the calculator to find out A and B. You could also do it in Excel, but I don't know how to do that. What else? Same thing on this one. Same on that one. Okay, so this one, how is the coefficient of determination found? So this is just saying R squared is the coefficient of determination, and how do you find that? Yeah, squaring the correlation coefficient R. In the next part, given R is 0.47, find the coefficient of determination and non-determination. So the coefficient of determination R squared is just R squared. So this would be 0.47 squared. So that would go here. And then the coefficient of determination is the percentage of variation in Y explained by X. So you would just put the percentage, this number here as a percentage here. And it would be due to the variation in X. And the coefficient of non-determination is just 1 minus R squared. So you'd take R squared and take 1 minus that. And then you would put that value here. And then you'd put the percentage. So just that as a percentage there. And this would be not due to the variation in X. Everyone okay with that? Great. And that's how you do chapter 10.1. There. Okay, now that was all the examples I had for that part. Let me go back somewhere else. Oops. Stop share. Share screen. Start. Okay. Let's go back to where we were. So now we're in chapter 6. So this is whenever we talked about the normal distribution. So know some properties about it. So as it relates to central tendency. So I'm just saying for a normally distributed random variable, the mean, the median, and the mode are all the same. So that's true for any symmetric distribution. So if I give you, for instance, the mean of the distribution is equal to 10, and it's normally distributed, I ask, what is the median or what is the mode? It's just the same thing, it's 10. Then the next thing we talked about was how to find z-scores. So if you're looking at a population data, then you can find it by taking the data value of interest x minus the population proportion mu, not population proportion, population mean mu, and then dividing by the population standard deviation sigma. Then if you wanted to do it for a sample, you just replace mu with x bar, so the sample mean, and s by the sample standard deviation. Does everyone remember how to do that somewhat? You should probably expect a question on the exam that says find the corresponding z-score and the associated probability. So that is probably the one that people most often on the exam. Then you should be able to use the calculated z-score to find the associated probability in the standard normal table. So for instance, you should be able to find the probability of z being less than or equal to some little z-score is equal to something. So all you would do in the table is look at what is the corresponding little z value and just look at the area to the left of it. If I wanted the probability to the right of it, what would I do? Take 1 minus the area to the left of it. So there were some examples that we did in the notes and some on the practice. I don't know if there's one on the practice exam or not, but I'll go over one. Then chapter 7. This part one is quite long. So this is all about confidence intervals. So know how to identify the pieces of the confidence interval and calculate them. So the first thing we talked about was the general form of a confidence interval. So it was a point estimate plus or minus the margin of error. And you could find the margin of error by taking the critical value and multiplying it by the standard error. So when there were 3 different confidence interval forms we looked at. So for the population mean mu, when we knew sigma, so in that case, we used a critical z value and the population standard deviation. And you could find the confidence interval as the point estimate was x bar, which is the sample mean, plus or minus the critical z value times the standard error, which is sigma over the square root of n. Now, as the sample size increases, what happens to the standard error? Does anyone remember? Does it increase, decrease, or remain the same? So as I increase n, but I keep the standard deviation the same, this part right here, sigma over the square root of n, is getting smaller and smaller, correct? So therefore, the standard error is decreasing, so therefore the margin of error is decreasing. Let's see what's another one. As the confidence level increases, what happens to the width of the confidence interval? Does it increase or decrease? It increases. And why? So as I get a higher and higher confidence level, the area between the 2 critical values is getting larger and larger, right? So therefore, my critical value on the left-hand side is getting more negative, and my critical value on the right-hand side is getting more positive. So that just means this z alpha over 2 is getting larger, therefore making the confidence interval wider. And as the confidence level decreases, the width decreases. So then we talked about for mu when we did not know sigma. So in this case, you just used a critical t value and you looked at the corresponding sample standard deviation. And how do you find the degrees of freedom to find the critical t value? Yeah, n minus 1, just the sample size minus 1. Then the thing that most people struggle with are finding the critical values. So I kind of put a thing down here that may help you do it. So critical z values. So this is whenever we have the probability of z is less than or equal to some negative z alpha over 2. And the area to the left of that is equal to alpha over 2. And I mentioned the confidence level is equal to 100 times 1 minus alpha %. Or you can find the positive critical value by using the probability of z being less than or equal to z alpha over 2 is 1 minus alpha over 2. Equivalently, you could say the probability of z being greater than or equal to z alpha over 2 is equal to what? So if the area to the left is 1 minus alpha over 2, the area to the right is just alpha over 2. And in these 2 instances, why is alpha divided by 2? Yeah, it's a 2-tailed confidence interval. Then for the critical t values, you can find those by finding the confidence level at the top. So this is whenever we did confidence intervals. You could find the confidence level at the top. It says like 90, 95, 99. And you could intersect it with the corresponding degrees of freedom and just take that value, and that's your critical T alpha over 2. Then again, I put here, know the relation between the confidence level and the significance level alpha. So the confidence level, which is like 90%, 95%, 99%, is just equal to 100 times 1 minus alpha percent. So if I give you a confidence level, you should be able to know how to find alpha, or if I give you alpha, you should know how to find the confidence level. Is everyone okay up to there so far? Great. Then chapter 8 was where we started talking about hypothesis testing. So the first thing we went over was the null and the alternative hypothesis and what was the definition of each of them. So you should probably know the definition of each. So the null hypothesis states there is no difference between a parameter and a hypothesized value. And we looked at the different forms that could take on. So it was, for instance, in chapter 8, it was mu is equal to some hypothesized mean mu naught, or P was equal to some hypothesized proportion P naught. And then the alternative was obviously the opposite. So there was a difference between the parameter and the hypothesized value. So there was 3 relations we could have. It's either not equal to, less than, or greater than. And then we talked about some ways you could identify that. Then the first section was all about, or I guess we'll talk about the critical values first. So finding the critical values based on alpha and what tail it is. So I do this for a Z and a T. So for a left-tailed Z test, so that means the alternative is less than. The critical value, which is denoted minus Z alpha, has the property that the probability of Z being less than or equal to minus Z alpha is equal to alpha. So all you need to do is look at the corresponding area to the left of alpha, and then find the corresponding Z score with that area to the left. Does everyone remember that? Then for a right-tailed test, the critical Z value, denoted Z alpha, has the property that the probability of Z being less than or equal to Z alpha is 1 minus alpha, or equivalently, the probability of Z being greater than or equal to Z alpha is what? Alpha. It's just saying that the area in the right-hand tail is alpha. Then for a 2-tailed Z test, you have minus Z alpha over 2, which is the negative critical value, has the property that the area to the left of it is alpha over 2. And the area to the right of the positive critical value has area 1 minus alpha over 2. Or the area to the right of the positive critical value is just alpha over 2. Does everyone think they could find the critical values if I give you the value of alpha, at least for a Z test? Okay, we'll talk about some examples next time too. Then we move on to a t-test. So this one you just use the table. So for a left-tailed t-test, you want to look at the one-tailed alpha. So there's one tail and two tails for alpha. So look at that one-tailed alpha value and then intersect it with the degrees of freedom, which you can find by taking the sample size -1. So it'll only give you the positive critical values in the t-table, so make that value negative. Then for a right-tailed test, you will do the same thing. You look at the one-tailed alpha, intersect it with the degrees of freedom, but you just take the positive critical value in that case. Then for a two-tailed test, you look at a two-tailed alpha in this case, since you're doing two tails, you intersect it with the degrees of freedom, and then you take the positive and the negative of that value, and those will be your two critical values. So note how many critical regions there should be depending on what tail your test is, your alternative is. So if you have a left-tailed test, how many critical regions will there be? That just means how many regions will you reject the null hypothesis in? One, yeah, just the area to the left of the critical value. What about a right-tailed test? One, yes, the area to the right of the critical value. What about a two-tailed? Yep, the area to the left of the negative and the area to the right of the positive. Then the decision rules. So I just did this in general. So for a left-tailed test, you reject the null hypothesis if you get a test statistic that is less than the critical value. So in most cases, the critical value will be negative. So it's just the probability of getting a test statistic more negative than the one you got for the critical value. For a right-tailed test, you're looking at a test statistic greater than the critical value. And then for a two-tailed, it's if you take the absolute value and that's greater, or dang it, that should be greater than the positive critical value, not less than. What the? This here should be greater than. What is another way you could do the last one? Reject the null hypothesis if the test statistic is less than the negative critical value, or if the test statistic is greater than the positive critical value. Either of those things mean the same thing. Then I was even nice enough to tell you how to find the p-values. So conducting a hypothesis test for the mean when sigma is known and finding the associated p-value. So this was doing a z-test for mu. And you can find the test statistic by the sample mean x bar minus the hypothesized mean mu naught divided by the corresponding standard error of sigma over the square root of n. Then for a left-tailed test, the p-value can be found by the probability of z being less than or equal to the test statistic you got. For a right-tailed test, you're looking at the area to the right of that test statistic, so you can find that by taking 1 minus the area to the left. Does everyone know why those signs are that way? Inside where it says the probability of z being less than or equal to and the probability of z being greater than or equal to. What is the definition of a p-value? Does anyone remember? The probability of getting a sample statistic in a magnitude more extreme in the direction of the alternative hypothesis. So if the alternative is less than, we're looking at the probability of z being less than the test statistic we got. If we're looking at a right-tailed test, we're looking at the probability of getting a z test statistic greater than what we got. If you're looking for a left-tail or a two-tailed test, then you're looking at either or. So the easiest way to find the p-value is to look at the area to the left of the negative test statistic and multiply it by 2. So be careful. Some of you on exam 3 multiplied the p-value by 2 when you shouldn't have. Did I put that in here? No, I did not. Also know how to conduct a hypothesis test for the mean when sigma is not known. So that's just a t-test, right? So you should be able to find the critical values based on, where is it? This part right here, you can find the critical values. Then you use the decision rule from this part And then once you calculate the t-test statistic, which is, I guess I'll write the formula down. Oops. Okay. What was the t-test statistic? How do you find it? X bar minus mu naught divided by what? Yeah, S over the square root of n. So that's the t-test statistic. So I don't expect you to find the p-value for that. You could do it with the calculator, but we're not going to go over that. You can find a range of p-values, but everyone gets confused with that, so we won't go over that. And the last type of test we talked about was a test for the population proportion p. So, and since it's a z-test, you should know how to find the associated p-value. So we could find the z-test statistic by taking the sample proportion p hat minus the hypothesized proportion p naught, and then divided by the corresponding standard error of p naught times 1 minus p naught over n, all under the square root. So there was one like this just on your exam 3, so you should know how to do it. And then if you're doing a left-tailed test, you're going to look at the probability of z being less than the test statistic you got, and that would give you the p-value. If you're doing a right-tailed test, look at the area to the right of it, or you can just take 1 minus the area to the left. And if you're doing a two-tailed test, it's the same idea. Look at the area to the left of the negative test statistic and multiply it by 2. Everyone okay? In chapter 9. So we started off, it's basically the same thing as chapter 8, but it was 2 parameters in this case instead of 1. So how to identify the null and the alternative. So it's just like we did in chapter 8, except you have 2 parameters being equal under the null hypothesis instead of 1. So in chapter 8, we had like mu was equal to mu naught. In chapter 9, it was mu1 equals mu2. And then you could have, obviously, the alternatives based on that. Mu1 does not equal mu2, mu1 is greater than mu2, or mu1 is less than mu2. And you have the same thing for P1 and P2. Then this one was also on your exam. Conducting a hypothesis test for the difference between 2 means when you know sigma 1 and sigma 2, and finding the associated p-value. So the test statistic formula was given as follows: x1 bar minus x2 bar divided by sigma 1 squared over n1 plus sigma 2 squared over n2. Gosh dang it, I missed a squared. So there should be a squared here. On your exam 3, what did I give you? Yeah, I gave you sigma 1 and sigma 2, so you had to know to square them. If you didn't, you got something that was like 168, which is obviously a gigantic test statistic. So be careful of what I give you. And then the p-value is found the same way. Do I need to go over that again? Great. Then for a t-test for the difference between the 2 means, so this is when you don't know sigma 1 and sigma 2. So you find the test statistic formula using the same idea. The difference between the 2 sample means divided by the corresponding standard error. But in this case, you don't know sigma 1 and sigma 2, so you estimate them with S1 and S2. Then to find the critical t-values, you need to know the degrees of freedom. So you need to know how to find that. So you use the smaller between n1 minus 1 and n2 minus 1 as the degrees of freedom. And then you use the one-tailed or the two-tailed alpha and intersect that with the corresponding degrees of freedom, just like you did in chapter 8 to find the associated critical values. And then the last thing in chapter 9, knowing how to determine which type of error could have been possible based on your decision. So you should also know the definition of what type 1 error is and what type 2 error is. So type 1 error occurs when you reject a null hypothesis when it's actually true. And then type 2 is just the opposite. So it's whenever you fail to reject a null hypothesis when it's actually false. So then using those two ideas, if you reject the null hypothesis, you could have made a type 1 error. If you fail to reject, you could have made a type 2 error. Okay, and we'll pick up on chapter 10 next time. If you don't have your graded exam 1, 2, or 3 back, come up here and get it. Other than that, I'll see you on Thursday.